Hello and welcome back to Advent of Code, Day 2. Day 2 opened about an hour, quarter ago. And yeah, the first day was pretty straightforward. Oh, put a login. Oh. Damn it, I gotta go dig up my code. Why did I do that? One second. I forgot to do this before the stream. So yeah, day 1 was basically Python sorting, Python list comprehensions. It's pretty straightforward. Like, they're supposed to remember your device, but every day I have to get a new two-factor authentication code for GitHub. I don't think it likes my device. Wait, why don't I have Wi-Fi on my phone? Oh, God. Hang on, I've got to open a different browser. Yeah. Just turn this off. Is it because your router doesn't have static IPs? Well, it seems to be no matter what router I'm on. I don't know. So... Alright, we're done. Alright, day 2. Hello, 77 Peaceful 77. Are you doing Advent of Code as well? Satisfactory also doing an Advent of some sort, so tempted to be streaming at Satisfactory each day after Advent of Code. Right, so what do we got? Day 2, Red-Nosed Reports. Fortunately, the first location the historians want to search isn't a long walk from the chief historian's office. While the Red-Nosed Reindeer Nuclear Fusion Fission Plant... are they referring to? Oh, this is the first advent of code. Cool. The engineers there run up to you as soon as they see you. Apparently, they still talk about the time Rudolph was saved through molecular synthesis from a single electron. They're quick to add that, since you're already here, they'd really appreciate your help analyzing some unusual data from the red-nosed reactor. You turn to check if the historians are waiting for you, but they seem to have already divided into groups that are currently searching every corner of the facility. You offer to help with the unusual data. The unusual data. You are only Python programmer streaming AOC, I found. Really, that's surprising. Because Python is a very popular choice amongst advent of coders. It's also a pretty competitive language, I would say, in terms of speed of code. Since the runtime of the code doesn't matter so much, it's usually seconds. Okay. I haven't really looked at people streaming. The only one I usually watch is Captain Coder. He does C#. Yeah, he'll be doing his later, I think. The unusual data, your puzzle input, consists of many reports. One report per line. Each report is a list of numbers called levels that are separated by spaces. For example, so one line is a report, each number is a level, okay? The engineers are trying to figure out which reports are safe. The red-nosed reactor safety systems can only tolerate levels that are either gradually increasing or gradually decreasing, so a report only counts as safe if both of the following are true. The levels are either all increasing or all decreasing. Any two adjacent levels differ by at least 1 and at most 3. Okay. In the example above, the reports can be found safe or unsafe by checking those rules. Yeah, alright. So we can check those two conditions separately. Well, we can well, I'm just thinking about how I'd actually write the Boolean condition. Yeah, we can say I can't describe it in words, let's just start coding. So this is what it looks like. Okay, it's not that big. Okay. Alright, so we've got day 2. We can copy some of this stuff. With open input text. So we got so let's just say reports equals an empty list. And then just change this to cast that to a list, so we're mapping that to a list of integers for each report. And we want to put that reports.append that. So this should be a list of lists. And what do we want to do? We want to check how many are safe. How many reports are safe? Okay. Okay, so just say safe count equals 0 for report in reports. Safe count plus equals, so the Boolean condition that's going to be true if it's safe is two conditions. So either they're decreasing at a rate between 1 and 3. So we want to say all report I plus 1 minus report I is between, so the difference, the second minus the first, is between 3 and 1 inclusive. Report for I in range, just say n equals length of reports. So the n minus 1. So it's that, or that. We don't need that extra bracket there. But this time we want I minus I plus 1. The previous one minus the next one. It's between 1 and 3. So this maintains they're all decreasing, or all, well, this one is all increasing and this one is all decreasing. It's got to be one of those. So we can't have an increase and a decrease in the same row. I hope that's right. I don't know if I'm allowed to tab like that. Let's see. Print save count. Yeah, it doesn't like doing that. Can we just say okay, we'll just put it all on one line then, whatever. I thought we could just press put that on the next line. Hang on, if I do that, that's okay. Just put it in the right place. Index out of range. Oh! No. N is not length of reports. N is length of the one report. That's what happens when you name a variable report and another one reports. The individual report. 483. Correct. Part 2. The engineers are surprised by the low number of safe reports until they realize they forgot to tell you about the problem dampener. The problem dampener is a reactor-mounted module that lets the reactor safety systems tolerate a single bad level in what would otherwise be a safe report. It's like the bad level never happened. Now the same rules apply as before, except if removing a single level from an unsafe report would make it safe, the report instead counts as safe. So we're working on Santa's nuke plant. Seems so. I've been working on a lot of nuclear plants lately. So we can remove one level. Oh, interesting. So alright. So for each report this time, we should probably just... So first check if it's safe already. Because removing an element could make it unsafe. So if it's safe as is, then it's safe. If it's not safe, we then remove each item one by one from the list and check if the result is safe. I don't think there's any way around doing that, because you can't... Because removing an item then adjusts the gap between the two outer items. So yeah, I think that's the way. So... this should be okay. So first, let's make a method to work out if something's safe, because this... we don't want to be writing this many times. So let's say... define safe of a list. Call it is safe. It's basically this, but n equals length of L. Return that or that. Oh, you do need the bracket. Okay, fine. But this is L. I don't like leaving gaps here. The IDE is doing that automatically. Okay. So that should... so now we can just say... is safe. Report. Don't even need this. And that means we can actually just simplify this whole thing to safety count equals sum of is... we can even do a map. We can do a map is safe reports. Sum map is safe reports. Does that work? Woohoo! Look how compact that is. Now we're being functional. So the map applies is safe to each item of reports. The sum goes over adds up all those iterables. Because they're booleans, it evaluates to 1 or 0. Depending on when it's true or false. Pretty cool. Alright, on to part 2. So that's part 1. So it's similar, but it's going to be like safe. Let's say safe count 2, and we want sum of Alright, we'll go through the for loop here. So for report in reports, so let's say safe count 2 equals 0. the Boolean condition this time. So either it's safe as is, or any list where we've removed one item is safe. How do we do that? So it's going to be any report up to I plus report I plus 1 onwards. So skipping item I. And I'm going to check if that is safe for I in range. So I needs to be so basically length of report. Does that look right? So either it's safe as is, or we try every value of I here, and for each one, so the last value will be n minus 1. So that's skipping the I value I. Yeah, I think so. 528. So it's slightly more safe. That's to be expected because we're relaxing the safety condition. So we can only get more safety. Correct? Okay. Yeah, that was a good problem. The key Python thing there was lists slicing, really. List slicing and Boolean conditions. So unlike last year where they threw a real curveball at us in day one, it's been quite straightforward so far. That will change, for sure. Yeah, last time it was really just, you get two lists of integers, sort them both, order them, smallest to largest, and then just add up the distances between A and B in each. Easily described in words. And part 2 was like, do the same again, except for each item in the first list, you multiply it by the number of times it appears in the second list. Add up all those numbers. Yeah, it's just lots of maps. Generators. Okay. Just have a look at the stats. Far less completion rate compared to yesterday around this time of day. Actually, I don't remember what it was yesterday. Oh, it probably was around, maybe it was around 10,000. Does any mean that if at least one slicing is true, it returns true? Yeah. What's more is it does short-circuiting. So as soon as it finds a condition which is true, it stops evaluating the remainder. That's pretty important because you might have errors in later conditions if you're assuming like you don't run off the end of lists and stuff. So yeah, you can assume that the moment it finds a true condition, it won't bother evaluating the remainder. And you can use all. Well, I used all, didn't I? Did I use all as well? All is the equivalent. Yeah, all, any, they're very useful in Python. they both short circuit. So as soon as it finds the first thing that's false, it stops evaluating. As soon as it finds the first thing that's true, it stops evaluating. Yeah, it's equivalent to... Basically, it's doing the union, Boolean union. I don't know, like in other languages, what is the equivalent. Like in C++, I would normally write a map where I'm unioning. I wouldn't be surprised if there's something similar in C++ now, but yeah, I think this is as simple as I can make it. This condition here is the bulky bit, but I wouldn't want to do it any other way. This seems the most readable to me. You could write it instead. You could. No. I think you really got to do it this way, because the danger is if you try to evaluate the two different conditions. One, it's decreasing or increasing. Two, every gap is between 1 and 3. You might get a situation where you go up by 1, down by 1, but you're accidentally counting that as safe. So yeah, this is really, I think, the safest way to do it. Can I have a look at the leaderboard? I mean, these are going to be seconds. 9 seconds for this. Not surprising at all. Although it's a big gap between that and the next ones. Well, 9 seconds for both stars. That's crazy. Like, could I even look at that and know what they want in 9 seconds? How is it possible? I hope they're not using AI, because it's not allowed, but it is plausible. I've like at the top end, you get competitors who will take a gamble. They'll just look at it. They'll pick out a few keywords. But then you've also got to deal with the site, like pasting in the answer. Well, they write all these scripts and stuff, so they just type straight into the ID, press a button, and it immediately submits to the site. So, and then they can write scripts that'll pull the description into their IDE as well, so that it minimizes the amount of faff with the website. It's possible. It's also possible that it was cheating, but I can't comment on that. If he's a known competitor, then he's probably not cheating, because these guys compete in lots of different sites and they don't want to get a bad reputation. So, I don't know. I mean, yeah, clearly there's a huge gap between him and, where is it? The others. But still, I've seen things like that happen in like Google Code Jam and stuff long before AI was a thing. Kian XYZ, but okay, so where is he in day 2? He's not even in the list. Okay, so I don't know. That you would have thought he'd be in the top list every day. It was ChatGPT. Someone found the commit that was later deleted. Okay, well that confirms it then. Yeah, I didn't want to go accusing anyone. Yeah, I have to say 9 seconds is very, very close to being impossible. Possible if you were to take a gamble on what you think they want you to evaluate. But if you were to be sure of what it was, yeah, I would say 9 seconds is a bit too fast. So they're gonna get removed then? Four seconds for day 1, and another 5 seconds for day 2. Yeah, it's... what did you say? Someone found the commit that was later deleted. So they... What do you mean by the commit? They actually uploaded their solution or something? Alright, so, oh, and I got my private leaderboard as well. Oh, okay. Let me have a look at this then. In that case, it seems like they were intending... They weren't... I don't know. I don't know if they were intending to cheat. Maybe they were trying to write a GPT solution out of interest, but they didn't intend for it to get to the top of the leaderboard or something like that. I don't know. Because clearly they haven't attempted day 2, so... Because some people do ChatGPT solutions for the fun of it, and they're allowed to do that as long as they don't get onto the leaderboard. They updated their bio on GitHub apologizing. Okay, fair enough. That seems like an innocent mistake then. I guess they might get removed, and whoever's next in line will take the place. But yeah, I mean, in 2 years ago, I think was the first year where this started becoming a problem, and at that point there was no rule against it, so it had to just be allowed because ChatGPT was just becoming known. In fact, that was how I first learned about it. I didn't know about it before then, but people were openly explaining how they solved it using ChatGPT. And getting to the top of the leaderboard for a couple of problems. It was a bit of a controversy because it wasn't against the rules, and some people were like, okay, it's a fair use of technology. Now people are pretty much broadly agreed that it's not fair, it's not welcome in the competition because it's defeating the point. Back then it was a bit confusing because it just wasn't clear what was or wasn't allowed. Since this is unfathomed, this is just not... No competition has had to deal with this kind of thing before. Can't imagine what situation that has created for the actual, like, competitive coding scene. The Google Code Jam, that's dead. That competition is dead. It's a shame. That was honestly the best, in my opinion, competitive programming competition. If they had kept going, I wonder what it would be like now, having to try and detect and filter out ChatGPT solutions. You can't. Like, people think they can detect it, but you can't. There have been studies that have been checking these so-called chatbot detector programs to detect if something, not necessarily code, but even like, I don't know, a CV or a piece of prose, to detect whether it's written by a chatbot or nothing. They're never accurate. They're like 50% accurate or something. So there's a lot of these sites which are claiming they have 100% accuracy. And a lot of universities are buying these products and then punishing students for writing solutions that were detected as being ChatGPT when there was literally just their... they didn't even use it. So it's crazy. The actual answer is you can't detect it, full stop. Anyone trying to sell you a product that detects ChatGPT is lying to you. Or they might not even be lying, because you can say that you have a detector with 100% accuracy. I could write a detector which always says, yes, this is ChatGPT. That would technically be 100% accurate, because every time someone uses ChatGPT, it does correctly say yes. That's the problem with accuracy. It's one-sided. You have to use a balanced... You have to balance the false positives against the true positives and so on. That's what the concept of recall and precision is. Precision and recall. You have to balance those two factors against each other to determine whether something's truly accurate. And this happens in the medical industry as well. It happened during the pandemic. People were developing COVID tests that they claimed was 100% accurate, but it was just suffering from the same problem. It was just always guessing you had COVID, which technically is 100% accurate. So yeah. Does ChatGPT just rip off GitHub anyways, like any normal programmer? Yeah. So when it first launched, it was trained on archives before a certain year. So, and that included older Advent of codes, so that would have helped it know how to solve newer Advent of codes. Now it's more recent, I guess, so it's more up to date. So yeah, it's probably seen a lot of Advent of code. It knows the patterns and stuff. Yeah, definitely it's trained heavily on GitHub. That's one of the best sources of knowledge for it. So these are like the formulas you use for like trying to balance the two. There's no right answer there though. Alright. Just wait 22 hours. Yeah, I think I'll usually go like 1 or 2 hours after it launches, because that's like the best middle ground between British people waking up and Americans going to sleep. It's around midnight for US when it launches, isn't it? I think Eric said that that's just the best time for him, because he has a job, a real full-time job, and a family and everything. So midnight is really the only time he can really launch it and be present in case there are problems, server overloads, mistakes in the code, etc. Although mistakes are very low. He's spent an entire year ironing this out. He's had a whole series of testers help him, so there's rarely any mistakes, if ever. Maybe 1 or 2 mistakes in the past, but not often. So it's usually, you started at midnight Central Time for the US. Yeah, I don't know what time Eric is on, but somewhere in the US. So yeah, whenever you think there's a mistake with the site for your particular test case, usually it's you've done something wrong. But maybe once or twice there has been a legitimate mistake. I don't know. Alright. Well, might come back with some satisfactory then, but not. I gotta go get lunch first. So, see you tomorrow then. I don't know when the hard problems are gonna start, but soon enough they'll start. Usually around problem 5 or 6 we start getting some nasty ones. Alright, thanks for watching. See you for day 3. Bye-bye.